Welcome to Factors and Prime Factorization. Some really important skill. I know I say that a lot, but it just really is. One really important thing is to understand the different uses of the term factor. It's sometimes used as a noun in math and sometimes used as a verb. A factor as a noun, it's a whole number that divides evenly into a number. For example, the factors of 12. 1 is a factor, 2 is a factor, 3 is a factor, and so on, because each of these numbers divides evenly into 12. But if you're given a number and the directions say factor or give the prime factorization, they're telling you to do something to the number. They're asking you to rewrite it as the number as a product. Scroll down just a little bit here. So if I wanted to factor the number 12, there's a lot of different ways. I just listed some of them here. 1 times 12, 1 times 3 times 4, 2 times 6, 2 times 2 times 3. It just so happens this last one is actually what we call prime factorization, because it is, each one of these factors is actually just prime. Well, you'll be asked to list the factors of a number. And sometimes it's not too tough if it's small, but the bigger it gets, the bigger the problem it becomes. So even a number like 56, it's easy for students just to think of their multiplication facts and leave things out. So when I ask you to write the factors, I will ask you to list them in order. But I don't think of them that way. When I'm writing the list, I write 1 at the same time that I put 56. And then if you'll just apply your divisibility rules, it will be helpful. So 2 goes because it's even. Excuse me. There's a yawn there. If you divide 2 into 56, you'll get 28. You might not be sure that 4 goes into it, but remember that little shortcut for divisibility rule by 4. It says cut it in half twice and see if you get a whole number. So 56 cut in half we said was 28, and if you cut it in half again, you get 14. So you know 4 times 14 is 56. And hopefully you know 7 times 8, because that's one of our multiplication facts. Once there's no numbers in between 7 and 8 that are actually factors, you know you're finished. That's the advantage of working from the outside in. So when you start, just leave a gap of space. And sometimes you'll leave too much, but it doesn't matter really. When you get to a number really large, like 180, that's really a problem for students to list all of this. Actually, it's a problem for all of us. So it's a pretty tough list. So we're going to learn a little bit about prime factorization, and then we'll come back to this list, and I'll show you how you can use prime factorization to make the creation of that list a lot simpler. So let's scroll down a bit. Oops. Keep writing on my paper. All right, let's go to the next page. Well, actually, let's talk about prime factorization a little bit. I apologize. I jumped the gun just a little bit too fast. Oh my gosh. And I'm writing on my paper again. Thank you for bearing with me, everybody. Prime factorization. We already said the verb factor meant to rewrite as a product. So to do the prime factorization means to rewrite it as a product, a multiplication problem, where all the factors are prime numbers. Well, most of the time, I'd say the factor tree is probably the most commonly used, but you can also use a ladder diagram. So I wrote a couple of examples for you here. These are using factor trees. I took the number 56. The beauty of the factor tree is to start, you can think of any product that you want to, any factors whose product is 56. 7 times 8 comes to mind first. Well, 7's prime, so either circle it. I highlighted it here, but let's circle it. 8, not prime, so you break it down into a product. 2 times 4, 2 is prime, so I'm going to circle that one. 4 is not prime, break it down into its product of primes, and you get 2 more 2's. We're circling them just because we're not writing them all even each time, so we don't want to lose any of the primes, so that's the purpose for circling them. So we'll just jump over number 2 just for a second, and let's scroll down and just talk about how you're going to write it. In prime factorization, if you don't write it in exponential form, it looks like this. So in this problem, it was 2, 2, 2, and 7. So all of these are being multiplied together. So you've got 2 times 2 times 2 times 7. Or if you write it in exponential form, which is the way I want you to do it, it'd be 2 to the third times 7. Then I did 180 similarly. 180 is a bigger number, so it takes a little bit more work, but it's still not that big of a challenge. I'll just circle all my primes. So you would just keep going until everything that you have on the bottom is prime. It's best to write them in order. So let's show what it looks like if it's not in exponential form. You have a 2 here and a 2 here, so 2 2's. You have 2 3's right here, and then the 1 5 right here. Excuse me. Can't stop yawning. So I wrote this product in exponential form, and that's the form we're going to shoot for. If you don't particularly care for the factor trees, you could use a ladder diagram. The hard part about that in some cases is to start it off, you have to choose a prime factor. So out here, you're always trying to put a prime factor. Whereas when you're making the factor trees, you don't really have to think about that. You're rewriting everything, and eventually you will get down to just prime factors. But 7 goes into 56 and it's prime. So you divide 7 into 56, you get 8. Then you divide 2 into 8, you get 4. 2 into 4, you get 2. And you keep going, so you divide by 2 to get 1. You have to get a 1 down here. So it says choose a prime factor, keep dividing by prime factors until the quotient is 1. So if you look at the list over here and you ignore the 1 because 1 is not prime or composite, you've still got 1, 2, 3 2's and a 7. So you get the same thing. So now you're going to just take a minute from the video, go to this link, and it's going to allow you to practice some prime factorization using the factor trees. Well, I hope you did well with your factor trees. We're going to back up right now and talk about how we can use prime factorization. It actually has a lot of uses in mathematics. The one that we're going to use in this lesson is going to help you create that long list of factors for a number. Sorry, one more yawn there. So suppose you're asked to list all the factors of 180. Well, first you could take find the prime factorization. Well, we already did this, and it's right here. We did that on the previous page. So if I want to list the factors, I would first start with 1 and 180, but there's a whole mess of them in between. So all I have to do really, and it's really handy, is look at these factors, and these prime factors will tell me all of the other factors that are in between. So I've kind of made a list here of kind of walking through each one of the things, but instead I want to just kind of do it with you and write our answers down here. But you can go back and read the other because it'll be hard to write down everything that we're going to say. So we'd start with 1, and I'll come over here and put my 180. And I know 2 goes because not only is 2 in the list, but this is even. But you really don't have to think about the divisibility rules right there. Just look at the factors. So 2 is a factor. Well, 2 is in this list, and over here you've got 9 times 5. That's 45, times another 2 here because this is only one of the 2's. And so 45 times that 2 is 90. Now, you can get the number 90 without doing that. I'm just trying to show you how to get it when it's not so obvious. And that doesn't really look like a 0 right there. Let's make that better. There we go. All right. We know 3 goes. We don't really have to think about that. 3 goes into 18, so 3 goes into 80. 3 times 6 is 18, so it has to be 60. But if we didn't know that, we would see 3 in the list. So if you take the 3, it's here. Everything that's remaining you have to multiply together to get this factor over here. So you can see that it would be 4 times one of the 3's, which is 12, times 5, which would give you 60. If we're not sure 4 goes, well, we know 4 goes because 4 is listed right here. 2 times 2 is 4. Well, so everything left over here, other than the 4, is the other factor. So that's 9 times 5, that's 45. This kind of just allows you to not have to get bogged down in long division. 5 is a factor because it's listed right here. And it would divide into it 9 times 4 times. So that's 36. This way, you really can't miss any factors if you just go in order and look for them. Like we know 6 goes because we have a 2 here and a 3. So if you take away one of these 2's and one of these 3's to get your 6, you'll still have a 2 and a 3. That'll be 6 times 5, which is 30. Sorry, lost my train of thought there for a second. Still working. We look up here. We know 7 is not listed. It's not a factor. 8 can't be a factor because I would need 3 2's to have an 8. So I don't have anything up here that multiplies together to be 8. 9 is a factor because it's listed there as 3 squared. So if you take away the 3 squared, just imagine that gone, you have 4 times 5, which is 20. I know 180 is kind of an easier number to think of the missing factors, but I'm just trying to show you what you would do when that wasn't the case. So 10 is a factor because here's a 5 and here's a 2. Just in case I can't tell by using my divisibility rules, I'm just showing you that you can get all of it by just using the prime factors. So 10 times 18, and these numbers are getting closer and closer together, which is a good sign for us. 11 is prime, and it's not in the list. 12, 4 times one of these 3's would be 12, so 12 is in the list. So if you take away one of these 2's, actually both of these 2's, and one of these 3's, you'll have 3 times 5 left, which is 15. Now the only numbers between 12 and 15 are 13 and 14. And 14 can't go because there's no 7 up here. So we've got our list. And if you go back, let's see, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and then all their partners, so 18 factors. If we go back to our page before and double check what we had then. Oh, that was on a previous page, sorry. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there were the other 9. So we produced the same list. Let's go a little further. Now let's practice this one. You might take a minute and see if you can list all the factors of 200 using the skill that we just talked about. Remember, first you need to do the prime factorization. See you in a minute. Okay, well, I've done the prime factorization. You could have started with something other than 10 and 20, but we all should have ended up with 2 to the third times 5 squared. I wrote it out without the exponents just because you might find when you're trying to list the factors, you might find it easier if you can see the whole list this way. So let's start with 1, and way out here at the end, let's put our 200. We'll work our way in. We see 2 in the list, so we put 2, and then all the rest of this multiplied together, that'd be 4 times 25, which is 100. Of course, we know 2 goes into 200 that many times. 3 is not in the list, it doesn't go. 4 is in the list because that's 2 of the 2's. So if you block that out, you've got 2 times 5, which is 10, times 5, which is 50. 5 is in the list. 5 times 2 is 10, times 4 is 40. Again, you can get it without this, but this is helpful. 6 cannot be in the list because there's no 3. 7 is not in the list. 8 is in the list because you've got 3 2's. So 8 times 25. 9, not in the list. 10 is in the list because you've got a 2 and a 5. So I'm getting really close together here. If I take out one of these 5's and one of these 2's, I'll have left 4 times 5, which is 20. In between there, let's keep going. I may have them, let's see, 10, 11's not in the list. 12, there are no factors that multiply to be 12. 13's not in the list. 14, no product equals 14. 15, no. 16, no. I'd have to have 4 2's. 17, nope, it's not in the list. 18, and now I'm right back up to 20. So there's not any between 10 and 20. So this is your list of factors for 200. Hopefully you got all of them. You do need to be able to list them in order. Have a great night.